Hello and welcome. Today, we invite you to explore the world of quantitative analysis using the CAMAG High-Performance Thin Layer Chromatography HPTLC system, brought to you by Ankrum Laboratory. The CAMAG HPTLC system provides you with the tools to perform both qualitative and quantitative analysis of chemical compounds in a variety of sample matrices. To achieve automatic quantification in HPTLC analysis, we rely on the powerful CAMAG visionCATS HPTLC system control software. In HPTLC analysis, once the qualitative analysis is complete, we move on to the quantitative phase. One crucial concept in HPTLC quantitative analysis is the amount of analyte in sample present on the plate. During HPTLC analysis, both the samples and standards are in solid form on the plate. Quantification involves the detection and measurement of these solid analytes. Let's consider the quantification of caffeine in a green tea sample as an example. The multi-level calibration curve method involves creating a standard solution of the analyte at a specific concentration and applying different volumes of that solution to the plate. In the case of the 1 mg per milliliter caffeine solution, applying 1 microliter, 2 microliters, 3 microliters, 4 microliters, and 5 microliters volumes to the plate corresponds to 1 microgram, 2 micrograms, 3 micrograms, 4 micrograms, and 5 micrograms of caffeine, respectively. We apply the same concept to the green tea sample. If we prepare a 100 mg per milliliter solution of the green tea sample and apply 2 microliters to the plate, we are actually applying 200 micrograms of the green tea sample. Similarly, if we apply 3 microliters of the sample, it means we are applying 300 micrograms of the sample to the plate. Quantification in visionCATS software after completing the densitometric scanning under the maximum absorption wavelength of the analyte of interest. Let's explore the Evaluation tab in the CAMAG visionCATS software. By clicking on the plus symbol in front of the SST option, the Evaluation tab opens up. Here, on the left side of the screen, we have 5 options: definition, integration, substance assignment, calibration, and results. Click on definition, and then click on the plus symbol in front of substances. Write the name of the analyte and select the calibration type based on the detection method used. For fluorescent detection, choose height, and for UV and visible detection, choose area. Now, click on References and input the concentration of the analyte standard reference. Proceed to the Samples tab and input the concentration of the samples. Ensure that the concentrations are as per the vial ID provided. Next, click on Integration and locate the small black arrow behind the wavelength used for scanning the plate after development or derivatization, depending on the user's needs. All tracks from track number 1 will be displayed. Click on singular tracks and check the RF values, area, and other important parameters in the peak table by entering manual mode. Select the track with the highest on-plate amount of the analyte standard reference. Integrate the corresponding peak of the analyte of interest based on its RF value detected after scanning and as shown in the plate image. The integration should cover the start and end RF values of the peak. The software will automatically integrate each of the analyte reference standard peaks. Proceed to substance assignment and assign the peak of the analyte of interest on the right-hand side with respect to the image of the band detected in each track at the same RF value on the left-hand side. This can be done by selecting the substance name from the lower part and placing it at the respective RF value position using the computer mouse. After substance assignment, return to the Integration tab and observe the name of the substance appearing at the top of the analyte peak. Click on Calibration. Here, you can view the automatically plotted multi-level calibration plot. On the y-axis, we have area values with no unit, and on the x-axis, we have the on-plate amount of the analyte standard reference with units such as nanograms, micrograms, etc. Green cross marks represent the O values of the reference standard points, while blue cross marks indicate the area values of the analyte separated from the sample matrix. To view the 3D view of the calibration plot, click on the wavelength and press Alt tab on the computer keyboard while right-clicking the mouse. Lastly, click on Results. Here, you can observe the amount of analyte detected in the sample. The software will show the concentration of caffeine detected in 1 milliliter of green tea sample. Also the on-plate amount of caffeine detected in each sample track. You can calculate the percentage of caffeine detected in green tea sample easily by using these results. Congratulations! You have successfully navigated the Evaluation tab. If you have any questions or require additional support, don't hesitate to reach out to us at Ankrum Laboratory. Visit and subscribe our YouTube channel. Thank you.